Welcome, boys and girls. My name is Nicole Harris-Kunusan, and today we are looking at our learning outcome. We wish to solve problems involving the multiplication of a fraction by a mixed number. Today we are going to be looking at three strategies. We are going to be looking at solving using the area model, solving the problem using the set model, and solving the problem using the linear model. We have three questions that we will be going through using all three models. Rita had 7.5 kilograms of flour. She used 3/4 of it to bake some cupcakes. How much flour did she have left? We are using the area model. First, we identify the whole area. Second, let us divide the whole area into two equal parts to get 2 halves. Here we see the whole area and 2 halves. Next, we divide each half into 2 equal parts, so we get 4ths. We have 1 whole, which is divided into 2 equal parts, 1 half, 2 halves. We have 1 whole, which is divided into 4 equal parts. Remember, 1/4 is the same as 1/4. I may use the two interchangeably. When I say 1/4, I am referring to a quarter. The question states, Rita had 7.5 kilograms of flour. She used 3/4 of it to bake some cupcakes. How much flour did she have left? We are going to use our fraction tiles to solve this problem. We need to find 3/4 of 7.5. You would have already looked at the distributive law. So if we're looking for 3/4 of 7.5, we can first find 3/4 of 7, then find 3/4 of 1/2, and put the two partial products together. Let's start with finding 3/4 of 7. We have the 7 wholes, which are all shown as quarters. Again, 1, 2, 3, 4, 5, 6, 7. Let us find 3/4 of 7. Each whole, we can identify 3/4. I would like to do this now. The first whole, 3/4 and 1/4. The second whole, 3/4 and 1/4. The third, the fourth, the fifth, the sixth, and the seventh. So we can see for all 7 wholes how we have identified 3/4 of each of the wholes. 3/4 of 7 wholes, we will be needing these. So 3/4, 3/4, 3/4, 3/4, 3/4, 3/4, 3/4. Let's see how many quarters we need in all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 3/4 of 7 wholes gives us 21 quarters. Let us focus on our 21 quarters. I would like to remove the quarters that we will not be needing. I would like to remove the halves, which we have already used. And I would like to take the 21 quarters and arrange them into wholes. Twenty-one quarters arranged into wholes gives us 1, 2, 3, 4, 5 wholes and 1/4 remaining. This means that 3/4 of 7 is equal to 5 and 1/4. Remember, students, we are solving the problem. Rita had 7.5 kilograms of flour. She used 3/4 or 3/4 of it to bake some cupcakes. How much flour did she have left? We spoke about the distributive law. We can find 3/4 of 7 and the 3/4 of a half and put the partial products together to solve the problem. We have already found that 3/4 of 7 is 5 1/4 or 5 1/4. Now, let us find 3/4 of 1/2. Here we have the whole. We can identify the half. We have 2 halves. If we break the half or divide the half into 4 equal parts, each part will be 1/8. 1/8 of the whole. We are always comparing our parts to our whole. 1/2 divided into 4 equal parts is the same as 1 whole divided into 8 equal parts. 3/4 of 1/2. Let's identify our half. And if we can see what 4/4 are, then 3/4 will be 1, 2, 3. 3/8. 3/4 of 1/2 is 3/8. So let's put it all together. Now, when we put our partial products together, we see our 5 1/4 and we see our 3/8. However, we know 1/4 is equivalent to 2/8. If I cover using my equivalence, it means when I sum the two partial products, my final answer is 5 5/8. 5 5/8 kilograms of flour. We need to know how much she has left. Let us complete so that we can get our whole 7.5. Here we have 5 5/8. 1, 2, 3, 4, 5 5/8. I am going to start adding to get the remainder. 1/8, 2/8, 3/8. So far I've added 3/8 and I now have 6. I'm going to add 1 whole. I now have 7. Remember, I added 3/8 and 1 whole. So far I've added 1 and 3/8. Now I'll add 1/8, 2/8, 3/8, 4/8. Remember earlier 4/8 was the same as a half. Let's check. 4/8 is the same as a half. So when I added 1, 2, 3, 4, 5, 6, 7 eighths and 1, I in fact added 1 7/8. 1 7/8 kilograms of flour were left. Our answer, Rita had 1 7/8 kilograms of flour left. Boys and girls, here again we have our problem. Let us solve our problem. Rita had 7.5 kilograms of flour. She used 3/4 of it to bake some cupcakes. How much flour did she have left? We used the area model earlier to solve the problem. Now, let's work it on the board. What is it we're looking for? We see that there are 7.5 kilograms of flour. And we know Rita used 3/4 of the amount. We want to know how much did she have left. So let's first calculate what is 3/4 of 7.5. Okay, then let us subtract the result from the total. Okay, we are going to calculate 3/4 of 7.5. This, we will use the operation for multiplication. We can write this as 3/4 multiplied by 7 and 1/2. We are going to be using the distributive property to solve the problem. So 7.5 can be written as 7 wholes and 1/2. The operation of multiplication distributes across addition. We want 3/4 multiplied by 7 and 3/4 multiplied by 1/2. Let's continue. Let's use a visual, a diagram to assist. We want all our wholes to be divided into quarters. Boys and girls, the idea is that the whole is divided into 4 equal parts. Let's look at the half. We have the whole. We can divide the whole into 2 halves. Let's divide the halves into 4 equal parts each. Can you see 1/2 divided into 4 equal parts, another half divided into 4 equal parts? Now, let's look at our 7 wholes. Let's look at our halves, and let us find 3/4 of each. In each whole, I am looking at 3/4. 1, 3/4, 2, 3. 1, 2, 3, 3/4. We continue. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21/4. We need to find 3/4 of a half. This here is our half. We need 3 out of the 4 parts. 1, 2, 3. In relation to our whole, it is in fact 3 out of 8 parts. 3/4 of a half is the same as 3/8. Let us put our partial products together. (21/4). We can take groups of 4s. We will get 5 groups of 4. That will account for 20, with 1 remaining. 21/4 is the same as 5 and 1/4. Added to 3/8. Using equivalent fractions, 1/4 is the same as 2/8. 5 and 2/8 added to 3/8. Our answer is 5 and 5/8. This is the same result we got earlier. Let's step back. We started calculating 3/4 multiplied by 7.5. we got to the part where we use the distributive property. We got our visuals to aid us. Let's continue from this point. I can write 7 as 7 over 1. When we're naming our fractions, we look at the value in the denominator. 1 tells us we are dealing with 7 wholes. We need 3/4 by 7 wholes added to 3/4 by 1/2. We multiply fractions, numerator multiplied by numerator, and denominator multiplied by denominator. 3 multiplied by 7, 4 multiplied by 1, added to 3 multiplied by 1, 4 multiplied by 2. 3 multiplied by 7 is 21, 4 multiplied by 1 is 4. 3 multiplied by 1 is 3. 4 multiplied by 2 is 8. Have we seen this before? Here it is. 21/4 is equal to 5 1/4. 5 1/4, we are looking at two fractions with different denominators. We can use an equivalent fraction for 1/4, which is 2/8. 5 2/8 added to 3/8 gives us a result of 5 5/8. We simply have one more step. What is it? Subtract the result from the total. Let's go forward. Our total is 7 1/2 minus 5 5/8. 7 minus 5 is 2. That means we have 2 1/2, and we still need to minus 5/8. Using equivalent fractions, 1/2 is the same as 4/8. We have 2 4/8 minus 5/8. Since 5/8 is a bigger fraction than 4/8, we need to do some regrouping. 2 can be written as 1 and 8/8. So this 2 we can now write as 1, and the 8/8 can be added to the 4. We now have 8 and 4, 12/8. And 12/8 subtract 5/8, we have 1 and 7/8. Neatening this up, our answer, Rita has 1 7/8 kilograms of flour left. Boys and girls, here is our answer, statement included. Boys and girls, we just showed how we can calculate 3/4 of 7 1/2 and then subtract the result from the total. I want us to find another way, or use another way, to calculate 3/4 of 7 1/2. We said we can write 3/4 multiplied by 7 1/2. Do you remember? We just used the distributive property. Now, let's work with improper fractions. 3/4 multiplied by 7 1/2. 7 multiplied by 2 is 14. Added to 1 is 15. We want 3/4 multiplied by 15 over 2. Remember, multiplying fractions, numerator is multiplied by numerator, and denominator is multiplied by denominator. We have 3 multiplied by 15 is 45, and 4 multiplied by 2 is 8. We can get 5 wholes. Since 48 will give us 5 wholes, leaving a remainder of 5/8. 8 into 45 will give us 5, remainder 5. Multiplying a fraction by a mixed number using improper fractions, we get 5 and 5/8. Just as we did before, we can now subtract the result from the whole. 7 1/2 minus 5 and 5/8. This we calculated earlier. Our answer was 1 and 7/8. Our answer remains Rita has 1 and 7/8 of a kilogram of flour left. Boys and girls, all that we have done so far, this is the strategy we used. First, we calculate 3/4 of 7 1/2, then we subtract the result from the total. Let's consider another strategy. This we will call strategy 1. This we will call strategy 2. How about we know she used 3/4 of the flour. That means she has 1/4 of the flour left. If she has 1/4 of the flour left, we need to only find 1/4 of 7 1/2 kilograms. Let's calculate 1/4 of 7 1/2. This we can write as I'm going to use the improper fraction to calculate. 7 1/2 can be written as 7 multiplied by 2 is 14. 14 plus 1 is 15. We can have 1/4 multiplied by 15 over 2. Multiplying fractions, 1 multiplied by 15, 4 multiplied by 2. That gives us 15/8. 8 into 15. When we divide 15 by 8, we will have 1 whole and 7 parts remaining. Again, this is our final answer. Rita has 1 and 7/8 of a kilogram of flour left. Welcome back, boys and girls. We are now going to look at multiplying fraction by a mixed number using the set model. Let's look at our problem. Dinesh had 3 3/4 cases of bottled water. Each case contained 24 bottles. He stored 2/3 of the bottles in the refrigerator and 3/5 of the remainder in the kitchen cupboard. All the other bottles were placed on the kitchen counter. How many bottles were placed on the kitchen counter? With our set model, the resource we are going to use would be counters. Let's look at our set model. We said that there were 3 3/4 cases. Each case had 24 bottles. We've taken all the cases with all the bottles and we have set them up where each counter represents a bottle. Therefore, we should be able to identify one case where we have 24 bottles, a second case where we have 24 bottles, a third case, again with 24 bottles, but 3/4 of a case, where we have 1, 2, 3, 4, 5, 6, multiplied by 1, 2, 3, 18 bottles. 24 plus 24 plus 24 plus 18. In total, 90 bottles. 3 3/4 cases of bottled water represents 90 bottles. We need to find 2/3 of the set. Now we are treating the 90 bottles as one set. Here we have our counters representing the 90 bottles. We can divide the set into 3 equal parts. Here we go. Can you see where each part has 2 rows and all our rows have an equal number of counters? This means that there are 30 bottles, another 30 bottles, and another 30 bottles. Our 3 parts have 30 bottles each. We want 2/3. We want 2 out of the 3 parts. Let's look at our question again. Dinesh had 3 3/4 cases of bottled water. Each case contained 24 bottles. He stored 2/3 of the bottles in the refrigerator and 3/5 of the remainder in the kitchen cupboard. All the other bottles were placed on the kitchen counter. How many bottles were placed on the kitchen counter? So we see where our 2/3 have been identified. Now, the yellow counters will represent the remainder, our 1/3. This needs to be divided into 5 equal parts. We need to get 3/5 of this amount, 3/5 of the remainder. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our remainder has been divided into 5 equal parts. But 3 of those parts, 3/5, were stored in the kitchen cupboard. Here we have our 3/5. 1, 2, 3, which was stored in the kitchen cupboard. So we have our remainder and our 3/5. So now we can identify our 2/5. 3/5 plus 2/5 will give us our whole remainder. If these are the bottles which were stored in the kitchen cupboard, then these must be the bottles which were left on the kitchen counter. Let's count how many bottles were left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 bottles were left on the kitchen counter. Boys and girls, we just did the problem using the set model. Let us continue. Dinesh had 3 3/4 cases of bottled water. Each case contains 24 bottles. He stored 2/3 of the bottles in the refrigerator and 3/5 of the remainder in the kitchen cupboard. All the other bottles were placed on the kitchen counter. How many bottles were placed on the kitchen counter? We have a problem. We know that Dinesh had 3 3/4 cases of bottled water. We also know each case contains 24 bottles. Dinesh stored 2/3 of the bottles in the refrigerator. Dinesh then took 3/5 of the remainder and stored those in the kitchen cupboard. All the other bottles were placed on the kitchen counter. How many bottles were placed on the kitchen counter? This is our question. Let's treat this as a multi-step problem. In the first step, let us find how many bottles are in 3 3/4 cases. We need 3 3/4 multiplied by 24. This can be written as 24 with 1 in the denominator, we can convert our mixed number to an improper fraction. 3 multiplied by 4 is 12. 12 added to 3 is 15 fourths. We see that the numerator has the value 24, the denominator has the value 4. 4 is a common factor for both 24 and 4. We can simplify. We say 4 divided by 4 is 1, and 24 divided by 4, it's 6. 15 multiplied by 6 over 1 multiplied by 1. That is equal to 90 over divided by 1. Remember, when there's 1 in the denominator, we are talking about wholes. 3 3/4 cases with 24 bottles each gives us a whole set of 90. Now, he stored 2/3 of the bottles in the refrigerator. Calculate. We need to calculate 2/3 of 90. Two-thirds of 90, we want 2/3 multiplied by 90. Remember, 1 in the denominator tells us we're speaking of wholes. 90 and 3 both have a common factor of 3. We can simplify. 3 goes into 3. 3 divided by 3, 1. And 90 divided by 3, it's 30. 2 multiplied by 30, 1 multiplied by 1. This gives us 60. 1 is in the denominator. It means we are speaking of 60 bottles. 2/3 of the whole set of 90 bottles is 60 bottles. He therefore stored 60 bottles in the refrigerator. If he stored 60 bottles in the refrigerator, then there must be a remainder. Out of that remainder, 3/5 go into the kitchen cupboard. Let's calculate our remainder. Our remainder must be the whole set of 90 bottles, subtract the 60 bottles in the refrigerator. Our remainder is 30 bottles. We need 3/5 of the remainder. We want 3/5 of 30 bottles. We can write 3/5 multiplied by 30. 30, 1 in the denominator, speaks of 30 wholes. 30 and 5, they have a common factor of 5. Let us simplify. 5 divided by 5 is 1. 30 divided by 5 is 6. 3 multiplied by 6 is 18. 1 multiplied by 1 is 1. 18, 1 in the denominator. We're speaking of 18 wholes. This means 3/5 of the remainder, which would be 18 bottles, were placed in the kitchen cupboard. 30 minus 18 is equal to 12. Where do these bottles go? We have accounted for those in the refrigerator. We have dealt with those in the kitchen cupboard. We were told all the other bottles were placed on the kitchen counter. These are all the other bottles. This means 12 bottles. This is our answer. How many bottles were placed on the kitchen counter? Our answer, 12 bottles were placed on the kitchen counter. Let us look at another strategy for solving this problem. Let's consider he stored 2/3 of the bottles in the refrigerator and 3/5 of the remainder in the kitchen cupboard. All the other bottles were placed on the kitchen counter. Are we really interested in the 2/3 stored in the refrigerator? No. Let's consider then what was not stored. 2/3 was stored in the refrigerator. The remainder must be 1/3. So let's deal with 1/3. 1/3 of 3/4 of the cases of bottled water. That's our remainder. So let us calculate the remainder. The remainder that is not stored in the refrigerator. 1/3 of 3 3/4. 1/3 of 3 3/4 can be written as 1/3, and we convert our mixed number to an improper fraction. 3 4s are 12, 12 plus 3 is 15. 1/3 multiplied by 15, there is a common factor between 3 and 15. We can simplify. 3 into 3 is 1, and 3 into 15 is 5. Or 3 divided by 3 is 1. 15 divided by 3 is 5. We want 1 multiplied by 5, 1 multiplied by 4. That gives us 5/4. 5/4 or 5/4, it's the same as 1 1/4. This means that 1 1/4 of the cases, that's our remainder. If we can find 1 1/4 of the cases remaining, then 3/5 of that was stored in the kitchen cupboard. Again, are we interested in what was stored in the kitchen cupboard? No, we're not. We're really interested in what was not. We want the remainder. If 3/5 are stored in the kitchen cupboard, then 2/5 must be what goes on the kitchen counter. 2/5 of 1 1/4. So calculate 2/5 of 1 1/4. We want 2/5 multiplied by 1 1/4. We can write 1 1/4 as an improper fraction. 1 multiplied by 4 is 4. 4 added to 1 is 5. This is 2/5 multiplied by 5 over 4. 5/4. 5 and 5, they both have a common factor of 5. 5 divided by 5 is 1. 5 divided by 5 is 1. 2 multiplied by 1. 1 multiplied by 4. This is equal to 2/4 or 1/2. Boys and girls, it is so important that we pay attention to our units. What are we talking about? 1/2 of the cases or 1/2 of the bottles? We are looking at 3 3/4. 3 3/4 qualifies the cases. We are talking about the cases. 1 1/4 cases. Again, the unit would be cases. We are looking for 2/5 of 1 1/4. Again, we are talking about cases. Should we put that in? Let's add it. So our unit would be cases. We know how many bottles are in one case. How many bottles will be in half of one case? We want 1/2 of we need 1 in the denominator tells us we're dealing with 24 wholes. 2 and 24, they both have a common factor of 2. 2 divided by 2 is 1. 24 divided by 2 is 12. 1 multiplied by 12. 1 multiplied by 1. 12. 1 is in the denominator. We must be speaking of 12 wholes. We calculate 1/2 of the 24 bottles. Our answer must therefore be 12 bottles are placed on the counter. So that's a second strategy we can use. Welcome back, boys and girls. As we continue, we look at our third problem. We would be using the linear model to solve our third problem. Atto trained for a marathon by increasing the distance he ran daily by 2/5 of the distance he ran on the day before. If he ran 3 3/4 kilometers on the first day, then how many kilometers did he run on the second day? We are going to be using paper clips as our resource for the linear model. We are told that he runs 2/5 more the next day. We need to find 2/5 of 3 3/4 kilometers. The way the length is set out, we can see that each kilometer is broken into quarters. It means that 3 3/4 kilometers actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 quarters. Let us divide the whole length into 5 equal parts. Each part has 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 paper clips. The 3 3/4 kilometers, the length, has been divided into 5 equal parts. We need 2/5. Here are 2/5. How many paper clips are there? 1, 2, 3, 4, 5, 6. We should notice that this represents 1 kilometer. This represents 1/2 of a kilometer. 2/5 represents 1.5 kilometers. It means that Atto ran 1.5 kilometers more on the second day. Let's look at our problem again. Atto trained for a marathon by increasing the distance he ran daily by 2/5 of the distance he ran on the day before. If he ran 3.75 kilometers on the first day, then how many kilometers did he run on the second day? Let's put our two lengths together. We can see 3.75 kilometers. And now we have 1, 2, 3, 4, 5, 6, 1.5 kilometers. How many kilometers are there in total? 1, 2, 3, 4, 5, and 1/4. It means that on the second day, Atto ran 5.25 kilometers. Boys and girls, here we have again our problem with Atto. Atto trained for a marathon by increasing the distance he ran daily by 2/5 of the distance he ran on the day before. If he ran 3.75 kilometers on the first day, then how many kilometers did he run on the second day? So let's look at our problem. What do we know? We know that daily he is increasing his distance by 2/5 of the day before. We also know he began the first day running 3.75 kilometers. Let's solve this problem using some steps. Let's see. I want to use a diagram to represent 3.75 kilometers. So let's get a visual. This is 1/2. This is 1/4. This is a half. This is 1/4. This is 1/2, and this is 1/4. If we have a whole, then this would be a half, and these would be our quarters. We have so we can see 3.75 kilometers. Let's divide this into equal parts. How many equal parts? 5 equal parts. We're interested in 2/5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We should be able to get equal parts of 3. 1, 2, 3, 4, 5. Does each part hold 3? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It means 5 equal parts represents 5/5. How many do we want? We need 2 of them. 1/5, the other 1/5. Therefore, how much of the entire distance represents 2/5? 2/5 is represented by 1.5 kilometers. 2/5 of 3.75 kilometers is represented by 1.5 kilometers. So What we need to do to find out how many kilometers he ran on the second day, we know we are increasing the distance by 2/5. We know that 2/5 is 1.5. Let's increase this distance by 1.5. So we need to add on we stopped here. 1, 2, 3, 4. This gives us a whole. This is a quarter. This is a quarter. This length is 1.5. If we have 1.5 represented by our 6 parts, then there are our other 6 parts. So, boys and girls, let's see if we can work this problem using another method. Let's think about what we know. Atto ran 2/5 of the distance of the day before in addition to the whole distance of the day before. So, if we put those parts together, 1 whole distance from the day before and 2/5 of the distance from the day before. Atto in fact runs 1 2/5 of the distance of the day before. Let's write that down. We know that the distance he ran on the first day was 3 3/4 kilometers. It means we are looking for 1 2/5 of 3 3/4 kilometers. We need to calculate 1 2/5 of 3 3/4 kilometers. We write 1 2/5 multiplied by 3 3/4. We are going to multiply two mixed numbers, but we can convert our mixed numbers to fractions. Let's do that. 1 multiplied by 5 is 5 plus 2 is 7. 3 multiplied by 4 is 12. 12 plus 3 is 15. Our numerator and our denominator, they both have a common factor of 5. Let's simplify. 5 divided by 5 is 1. 15 divided by 5 is 3. We want 7 multiplied by 3, 1 multiplied by 4. 7 multiplied by 3 is 21. 1 multiplied by 4 is 4. 21 can be divided by 4. We will get 5 wholes and 1 remainder. This means our answer is 5 1/4 kilometers. How many kilometers did he run the second day? Atto ran 5 1/4 kilometers on the second day. This is our answer. Boys and girls, today we looked at multiplying a fraction by a mixed number. We in fact used 3 models to solve problems. We looked at the area model, the set model, and the linear model. When we performed our calculations, we saw that there were different strategies you can use to answer the same question. Boys and girls, it's good to know the big idea in your problems. If we can use different strategies, we can check our work. I encourage you to learn the strategies so that it helps you to check your work and be confident of your answers. So, just to summarize today, we looked at multiplying a fraction by a mixed number. We saw to multiply 2 fractions, multiply a numerator by numerator and denominator by denominator. To multiply a fraction by a mixed number, we can use the distributive property. Take the mixed number, separate it into wholes and parts. Multiply the fraction by the whole, multiply the fraction by the part, and then sum the partial products. We looked at multiplying a fraction by an improper fraction. We again multiply numerator by numerator, denominator by denominator. And what about multiplying mixed numbers by mixed numbers? We saw you can convert a mixed number to an improper fraction. So if we convert both mixed numbers, again, multiply the numerator by the numerator and the denominator by the denominator. Boys and girls, thank you for viewing. All the best in your math journey towards the S.E.A. and stay tuned for more.